We are continuing our excursion into ratios and proportionality, similarity, proportions and similarity of triangles. And now we've come to where we're going to evaluate parallel lines and proportional parts. And we're going to start with this triangle proportionality theorem. And it states that if a line is parallel to one side of a triangle, and it intersects the other two sides, then it divides those sides into segments of proportional lengths. Now, that doesn't mean they're the same length, but they are in fact proportional. So in this triangle that we see here over on the right, we can determine that we do have two parallel lines. We've got one parallel line to one side of the triangle. We got the CD side, and then we have this BE line that is parallel to it. And they intersect the other two sides, AD and AC. And then it divides those two sides into segments of proportional length. So, in this case, we're saying that AB and BC, the ratio AB and AC, is going to be equal to the ratio formed by AE and ED. And again, that doesn't mean that they have the same side length. It just means that they are in fact proportional. And if we take the ratio of those two segments, then we can use that to help us determine a side length, which is what we're getting ready to do. All right, so here we have another triangle. Let's call this PQR. We got triangle PQR, and ST is parallel to RQ. And we can see that by these designations of parallel, that these are parallel lines. ST is proportional to RQ, and ST divides the side PR and PQ into segments. And so we should see a proportionality between PS and SR. That ratio would be proportional to PT and TQ. So here we're told that PS is 12.5, 12.5, and SR is 5, and PT is 15, and we're asked to find what is the length of TQ. Well, let's set TQ equal to a variable. Let's say that TQ is equal to, we'll just use X. So if that's the case, then we can take PS over SR, 12.5 over 5, and set that equal to PT, 15 over X. And again, order is important. We want to make sure that we got it in the right spot. All right, let's see. So let's solve for this. We're going to do a little bit of a cross multiplication. And so we got then 12.5x is equal to 5 times 15, it's going to be 75. 5 times 5 is 25. 5 carry 2. 5 times 1 is 5 plus the 2, 75. And now we're going to solve for x by dividing both sides by 12.5. And I think that's going to be 6, because 12 times 6 is 72. That's right, I think it's 12.5. Let's see, 75 divided by 12.5. And yes, x is in fact equal to 6. All right, so Shazam. All right, 12.5 plus 5 is 17.5. 15 and 6 is 21. So again, they're not the same length, PR and PQ. But because of those parallel lines, and one of those parallel lines intersecting PQ and PR, it gives us proportionality, and we call that the triangle proportionality, I should say, triangle proportionality theorem. All right.